Hello guys, this is Mr. Jaja. All right, we'll be talking about module 2 here, which is the switching concept. In here, we will look at, sorry, we will look at frame forwarding and switching domains. Frame forwarding, how does a switch forward a frame? So you have a term called ingress and egress. Egress is the entering interface and egress is the exiting interface. But every switch maintains a table called a MAC table. Some will call it a CAM table. Okay? So what does that CAM table or the MAC table does? The MAC table is going to get the list of all the destination hardware addresses and the corresponding ports they are connected to the switch. Okay? So the switch will use that MAC address to be able to send packets to the respective computers. So like I said, the switch MAC address table is also known as CAM table or content addressable memory table. Okay. The switch will, how does a switch learn about how does it learn about frames and forward them? So the switch will examine the source address, add the source address to the MAC if it is not there, reset the time out, setting back to 5 minutes if the source is in the table. Okay, the switch will examine will examine the source address and store it. Then the switch will examine the destination address. If the destination MAC is in the MAC table, it will forward it to that port. If the destination is not in the table, the switch is going to float out that information to all the ports. Okay. Switch forwarding methods. How does a switch forward packets or frames? How does a switch forward frames? There is what you call a store and forward switching. In a store and forward switching, the switch will receive the entire frame before starting to forward it. In a store and forwarding, the switch will wait and receive the entire frame. And then after receiving the frame, until the frame is completely received, the switch will start to forward it. Another method is called cut-through switching. In a cut-through switching, Babu, so in a cut-through switching, you have to, the moment the switch starts receiving until halfway of the frame, until the destination address, MAC address is there, the switch will start to forward the frame. So you can see this is an example of a store and forward. The switch have to wait until the entire frame is completely kept. Okay. So in the cut through, the moment the destination MAC address is captured, the switch will start to forward the frame. So switching domains. Okay. You also have what we call as collusion domain. Collusion domain, what is a collusion domain? Okay. A collision domain is an area of the switch environment where devices will compute to send. Switches eliminate collision domain and reduce congestion. So in a switch environment, every single port is a collision domain of its own. In a switch environment, every port is a collision domain of its own. You also have a broadcast domain. What is a broadcast domain? A broadcast domain is an area in the network where a broadcast is heard. Okay? It's an area of the network where a broadcast will be heard. So how do you alleviate congestion? Well, if a network congestion occurred, how do you alleviate it? You check the port speeds, where the port speeds can cause that alleviation. You have an internal switching also, whether maybe there are large frames or port density. Okay? So like I told you, this is a very short and precise one, chapter 2.